I want to focus on Snowpipe streaming with Apache Iceberg tables. In the past, we discussed about Snowpipe streaming as a real-time ingestion pattern or a streaming utility from Snowflake. But with Iceberg as a popular open table format because of its support for the interoperability, querying from different engines and a centralized data, how Snowpipe streaming works with Iceberg tables. Let us explore more. What we are going to cover: what is Snowpipe streaming? Why do we need Iceberg tables? How it works? What are different architecture types in Snowpipe streaming? Requirements and limitations. What we need to know before starting Snowpipe streaming, and why should we choose Iceberg? And then we will have a hands-on demo in one of our next sessions, but we'll focus more on the theory in this video. We'll also look at some best practices and some benchmarks are the difference between native tables and Iceberg tables when it comes to streaming. What is Snowpipe streaming? It is Snowflake's real-time ingestion service. Unlike file-based Snowpipe, it lets applications stream rows directly into tables as the data arrives. There is no staging required, no intermediate storage files. Snowpipe streaming is a real-time ingestion service offering from Snowflake. Data freshness. You would see the data in the target less than 5 seconds. So that is why you can say it as more close to near real time. Talking about throughput, right now it supports about 10 gigabytes per second, which is huge. And delivery via offset token tracking, it supports exactly once. That means once a record is loaded or ingested into target, it won't be duplicated. And it is serverless, that auto scales, no infrastructure to manage. It uses serverless auto compute under the hood. What are some ideal use cases? If you want to stream data from IoT or sensor telemetry, you want the change data capture, which means a frequent updates in databases, or fraud detection, where you want real-time attention to the fraud that is occurred, or live analytics, anything that is going live and you want to see the analytics, for example, sentiment analysis, or anything related to which product is going performing well in a particular window of time period during Thanksgiving, or like application events, like for example, if you are too many user events are happening on an application, you want to know those events in near real time or real time. And also Kafka topic consumption, where if your data gets pushed to Kafka topics from producers, Snowpipe streaming can be used as a sync connector to stream the data from Kafka topics to loads to Snowflake as a target. So these are some of the use cases that need to be considered on choosing Snowpipe streaming. What are Iceberg tables and why Iceberg tables? We talked about Iceberg is an open table format. Right now, Snowflake supports AWS, Google Cloud, and Azure. And if you have your data present in any of these clouds, you create a managed Iceberg storage table, and then you can access the data from these cloud providers. Interoperable, what it means, you have multiple query engines can read the same files that are present in your cloud storage, and you own the storage. You provide the cloud provider only for the storage, where Snowflake manages the metadata and its catalog. It doesn't manage the raw file, but it does supports metadata and catalog maintenance. It also supports open catalog sync. While open catalog from Snowflake supports interoperability, that means multiple query engines can read write, and it is a federated catalog for governance. And you have different Iceberg versions, V2 and V3. There are several features released part of V2 and several improvements which are done in V3. And then Snowpipe streaming high performance architecture supports both V2 and V3, whereas an older version of Snowpipe streaming, which was also called classic architecture, supports only V2. Full SQL access. Iceberg tables behave just like native Snowflake tables. You can perform select or any DML operations, time travel, and the time travel currently supported only for V2 for Snowpipe streaming Iceberg tables. How it works, the architecture flow. Consider you have a Kafka topics or you have an application as a source, and you introduce an SDK layer, a Python script, and you import required Snowpipe streaming SDKs, and then leverage an SDK, Python or Java, or the Rust core that are supported from Snowflake, and then read the data from the Kafka topics and write into Snowflake, and write into Snowflake Iceberg managed tables. But what happens between the SDK layer to the final queryable table? You will have a pipe object created, and there are channels created to parallelize, and then you would also see a Parquet plus Iceberg metadata file created during the transmission, and you would need an external volume because it has to know which cloud storage that it has to write the data to. And finally, it would also create a table that is queryable in Snowflake. These are the list of steps that are needed. And then some of the concepts that we would have to carefully observe for Iceberg specifically is the max client lag, the channel, and the offset token. What is max client lag? We can describe more on that, but default is set as 30 seconds for Iceberg tables, whereas it is 1 second for standard Snowflake tables. Why you would use max client lag? It is to control the flush interval, which means you're saying if it is an iceberg as the target, hey, wait until 30 seconds, get all of the data, and write into target. When you write, you're actually accumulating some data for those 30 seconds and writing it. The max is 30 seconds. Whereas for Snowflake native tables, it is only 1 second because the Snowflake has the ability to stream the data into micro partitions, and under the hood it uses a high performance architecture to read that the data which is stored in Snowflake. Channel is an ordered ingestion lane, maps naturally to Kafka topic per partition. Offset token, it enables exactly once delivery, and you could also replay on recovery. What are the two architectures and which one to use? Latest release from on the Snowpipe streaming is high performance architecture, The older one is called classic architecture. When it comes to features, the latest one supports both V2 and V3, and it'll also support Python and Java. It uses a pipe object that helps to improve the throughput, and the max client lag is set to 30 seconds for the Iceberg tables. And schema evaluation, it is only supported for standard tables, not for Iceberg tables. The throughput is up to 10 gigabytes per second, which is huge. And the status, which means whether which one to is recommended to use, it is better to use high performance architecture given the throughput and the pricing. The classic architecture supports only V2, and then it only has Java, Snowflake ingestion, SDK. There are no channel concepts. And then that was using 30 seconds for Iceberg max client lag. Schema evaluation standard tables only. And throughput is typically lower compared to high performance architecture. And Snowflake plans to deprecate classic architecture given the benefits of high performance architecture for the customers. What are some key requirements and limitations when you are setting up Iceberg table to stream the data from Snowpipe streaming? You definitely need an external volume because you have to write the data into your cloud storage, and use Snowflake as a catalog. You cannot use Glue or Hive or different other REST catalogs to write into to write using Snowpipe streaming. And use SDK, which is greater than 3.0, also new high performance Python Java SDKs. For classic one, we should use SDK 3.0.0. For the new high performance Python and Java SDKs, you can bring the latest SDKs available. Enable Iceberg streaming equals to true is needed in profile.json, and that is primarily for the classic json.profile. Usage grant and external volume is needed because you would typically use external volume to read and write the data into the cloud storage, and it is supported only for Snowflake managed Iceberg tables. What are some key limitations? You will not be able to create a partition Iceberg tables if you want to use Snowpipe streaming. Schema evaluation is currently not supported. When you're defining a varchar, an example of varchar 100 is not supported, so you convert that into a string. Snowflake catalog supported, not the Glue or Hive, and only Snowflake catalog is supported. We also see public sector entities cannot use embedded Oracle connector. Iceberg v3 requires high performance architecture only. We talked about max client log, the latency control knob. The difference between native tables and Iceberg tables for max client lag is 1 second versus 30 seconds. Why typically max client lag is used? It is the maximum time the SDK buffers rows client side before flushing to Snowflake. That controls the trade-off between data freshness and file efficiency. And if you use native tables, you would see in 1 second real-time elapsed time, whereas in Iceberg tables you need a default of 30 seconds because very tiny small Parquet files, they would create a problem for performance. So you would expect to write at least some larger or medium files so that the performance is not hit. The trade-off, setting a lower lag versus higher lag, you will see a latency of faster visibility when you set lower lag, and when you set a higher lag, it is slower visibility. File size, more small files if it is lower lag. Higher lag is fewer large files. The cost is higher when you use lower lag because it continuously has to rewrite those files for batch. Whereas if it is higher, it is more efficient with a higher file size. Snowflake recommendation is do not lower the iceberg lag below 30 seconds unless throughput is very high. Small Parquet files severely hurt query performance. I want to compare the native tables versus managed iceberg tables and their performance. Let us explore on lag, query visibility, file format, schema evaluation, pre-clustering on ingestion, partition tables, cross-engine access, storage cost, small file risk, and max throughput. Everything that these features are supported in native table with high performance. The only caveat is cross-engine access. Typically, if it is a native table, you will not be able to access the same native tables from other query engines such as Spark or Trinor. So you would need a catalog integration for that. Um, Otherwise, if it is a managed Iceberg tables, you can see a default lag of 30 seconds and query visibility simply little um, later than native tables. And schema evaluation, clustering, and partitioning is not supported. And there is a risk of small files, so that is why you have to wait for bigger files for a better throughput and performance. So, best practices, a cheat sheet, streaming to Iceberg. What you need to do? File size. The way you want that file size to be about 128 to 512 MB per Parquet file. And the data types typically use string instead of varchar. Max client lag by default set to 30 seconds. It is good to not change that. Lower only if rows per second is very high. Schema design, add variant catch all column. Iceberg has no schema evaluation on streams. So channels, one channel per Kafka partition, reuse the same channel name across different sessions. Batching is 1000 to 10,000 rows per insert call. Never insert one row at a time. It's not good for Iceberg. It'll create multiple tiny files. Offset tokens that persist offset only after success. Never pre-increment enables exactly once delivery. So it will avoid the duplicate data. Compaction. Schedule optimize daily via task. Snowflake won't auto compact Iceberg. So there is a schedule is needed for optimize. Base location. Unique prefix per table and never shared. So shared the location corrupt Iceberg metadata. Monitoring. Alert on growing partition scan. Raising scan count that is equals to small file accumulation. So these are some important considerations are the best practices before we streaming the data into an Iceberg table using Snowpipe streaming. So better start with this high performance Snowpipe streaming architecture. Also limit the file size to 128 to 512 MB. Tiny files are not good. You see a performance degradation or issue. Max client lag is set to default, lower only if you see a higher volume coming from the source. Keep the batch for about 1000 to 10,000 rows per insert call and enable these offset tokens, compaction, schedule the compaction, um, and use the base location for Iceberg volume and enable the alerts on the monitoring dashboard. So these are some important steps to consider while streaming the data to Iceberg table via Snowpipe streaming. So in a nutshell, what we discussed is what is Snowpipe streaming, and we talked about Iceberg files and leveraging high performance architecture. We also talked about 30 seconds default lag that is important for Iceberg, and also knowing the limits of not supporting partition tables and schema evaluation and certain worker columns for the Iceberg tables via Snowpipe streaming. So with that, we have covered how to use Iceberg tables with Snowpipe streaming to ingest large volumes of records into Snowflake and make the data more interoperable, to use different query engines to query the same data via managed Iceberg table in Snowflake that is loaded via Snowpipe streaming service. Thank you.